For the next 30 minutes, sit back, relax. We're going to hack lab. This is a tool. We'll look at it, how it works and stuff. So about me, I build tools. I know nothing other than Python. I just use Python. Yeah, the last line is important. If you got any names to fill in, please do fill those. Yeah. So what we are going to talk about today is a web testing framework. Oh, and as soon as I say web testing framework, I get this reaction. Like, there are too many tools out there. Like, why do we need one more thing? Like, why? Then I tend to explain it this way. Like, what are the real requirements that any web application tester has? These are the things. I try to get it down. First of all, we need the ability to run commands without touching the CLI, because who has the time to recollect the CLI flags, how is the output, how to parse it, or how to feed the output of one tool to another, or other thing. We need some storage. Like during a pen test, I found some good passive resource which can be used to test some site, and then I want it to be available to me for the next test as well. I don't want to go on searching every time I do a test. Some other things, like I need to have each and every HTTP transaction that happened during my test in a single place. Like, you keep running tools, all the transactions are scattered, you cannot search them. Many of the good tools don't even tell you what request they are sending, they just give you the URL. They don't, unless and until it's marked as vulnerable, you don't get to see the request, which is, not good on my part. Yeah, we need something free, obviously. We Indians we are cheap guys, we love free stuff. Other than that, yeah, we need a checklist as well. Like, we need to have something. Okay, I tested this. Come on, next. I tested this. We need that as well, so that we don't miss on crucial parts and stuff. As soon as I say all these things to people, then people give me this. What? Do you really think that can be done? Yeah, actually, I don't think you are aware of it. We actually did this. So this is OWASP OWTF. OWTF doesn't stand for what you think. It is Offensive Web Testing Framework, started by this great man, very smart person. It was first demonstrated at Brucon. It was a lightning talk initially. Formally putting, this is what the tool does. It's better to go and see what it actually means. How do we achieve what all I told you? Like, we have to give users an interface for their to organize their pen test, to use everything. Like, our aim was to user, okay, he will open his browser, open our framework, that's it. He can just test his site for whatever he want. He must not move away from the browser. So OWTF has many things, like we classify tests into different things based on different testing guides. So these are the few things which we do. We run tools, all the great tools. We present the output to user, like you can launch them. Some of the things which you don't have in tools, like few few things like let's say robots.txt is present, but let us say it has too many entries, you have to deduplicate and stuff. But yeah, we craft some special requests for that, and we parse out information and get it done. And yeah, we have a transaction database which does the, and yeah, the knowledge repo thing, I already told you, we collect all the best resources available for you, so that you can just click on those links and input your test site. Like, in many of the cases, what happens is we generate Google Docs automatically, so that you don't have to go open Google and in URL this. That is dumb. Who has time for that? We just got time to click. And yeah, we must obviously help user in his analysis. That is what is required at the end time. You run all those tools, if you don't have time to analyze, it's not worth it really. So a bit about the project, like how big is the project can be seen from this. Like, I don't know what this model is, but 235 years is a huge long time. Like, it started 3 years ago. So yeah, a quick overview of the features. We have a really cool web interface which was recently built. I built it actually. Yeah, this is where you can see your targets. This is from where you can maintain your sessions. These are the targets, these are the severity levels and stuff. And plugin classification, this is important because test classification is really important. You just don't go all guns blazing at once. That is not recommended. first thing you try things, and then it is almost like playing chess. Like you base your move on your previous results. This is what we do. We divided all the tests into different categories, which will let you, like before getting permission as well, you can just use passive resources. Even what passive resources does is they don't even send a packet to the target. We just use third-party, resources to get things done. And yeah, grab those. Apart from web, we also have some net plugins and aux plugins, which are fine at the moment. This is a screenshot of active plugins like the huge guns, the Terminator type guns. We have you can see most of the tools here. Like this is for every plugin we have this plugin type. We have plugin category. It's a web category. We have an OWTF code corresponding to it. You can see that it is somewhat similar to our OWASP code. And then we have a help text to help users. Like, come on, okay, old backup and unreferenced files. What does it mean? Like an Indian cannot understand that sentence, so he needs this line. Yes, this is really important. I want you to focus on this. You launch a tool, your internet connection is down. You don't want to be there. It's really bad. So this is somewhat, this allows you to control your plugins. Like you launched something like Arachne or something, and your internet crashed. You can just pause Arachne where it is, and as soon as your internet connection is back up, you can resume it. This is simple Linux signal stuff, but one of the important features, like we didn't understand until I had a power loss during one of my tests, and I was like, so this is important. Yeah, like how do we collect all the transactions from all those tools? We run a bunch of tools and our own requests. We need all those requests because, see, every bit of information is crucial for us. We really don't want to miss those tiny transactions. So we have our own inbound proxy, which I built it in GSOC 2013, it was benchmarked as the fastest Python proxy at that time. You can use it with any of the tools you run, which are like, apart from OWT, if you run any tools, you can run it using this proxy. You can use this proxy in your browser so that while you are manually testing it, all those transactions get recorded as well. And all the tools we launch are proxified, so we have each and every transaction ever launched by a tool. Whew, that's a huge data. So yeah, with the huge data, we need a good interface for giving the ability, to search stuff. So this is a part of screenshot of our transaction log, as we call it. As you can see, you can search using response codes, request methods. You can directly search request, response headers, or the response body content, or the URL as well. Yeah, nothing is complete without the ability to slide through search results. So this is after your search, you search something. This is really important so that you can understand like which transactions are matched. For example, in this case, I searched for some 500 response codes, and out of approximately 2,000 transactions, 122 matched, and this is the 13th of that. So these stats are really important. Like, for example, you are searching for, something which is common. For example, you are searching for a CSRF, this thing, what do you call it? You can simultaneously search for a form and then a CSRF token. And if you don't have a match in the number, it means some form doesn't have a CSRF token. You understand what I'm saying, right? Like if a form doesn't have a CSRF token, the match will not be there. Yeah, we have all the URLs as well. This is really important because we really don't want to miss anything, any URL. Yeah, but we really never wanted to do the whole process of building a spider again, which is really clumsy. So what we do is, it's not written here, but we call it scumbag spidering. We steal stuff from other tools. We pass the tool output and we get all the URLs that are found by it. So you can you can use any Ajax spider or anything, and OWTF will get it. So you have everything which is searchable. Come on. Then we have awesome plugin reports, as I already told you. And this is somewhat how our target plugin report looks like. This is the code and stuff. Yeah, you test for different stuff and it turns out here. Yes, this is another important thing. Like, you have to assist the user in his analysis. You don't come in user's way. You have to help him. So for every plugin, You have something to write down your notes, and you have some ranking as well, which can help you on make out the risky areas and this thing. Well, here the important point is this one. As I told you, we need a checklist to verify if it's done or not. By default, we support 3 standards. It is really easy to add your own. Like, we support OWASP V4, which was released some time ago. So yeah, that is really important. You can use it so that all your results will get reorganized according to that. So you can proceed like that. So it really does. You don't have to stick to any one of them. You can have your own mappings as well. Okay, here comes the demo. Come on. This is our interface first. What we will do is we will launch some. We'll add some targets first. That is the place to add targets. You can add multiple targets at once, and then this turn over here. And yeah, we will launch some spider plugins against Facebook. I'm searching here, and then I'm selecting. I'm not selecting the external one. And the grab one after that. Passive and semi-passive. Let's see what they are. After that, let me launch a plugin on demo.test file. I thought Arashni was better because it is really huge. This is to show the search capabilities. You can search for any tool or any specific keyword. So we launched 2 plugins right now. Let's go back to Facebook and see. That plugin might have already completed. So this is how the plugin report appears. You click on it, and then you get the types. We launched both the plugins. So passive plugin, you get the runtime, you get time interval, the status of the plugin, if any output files, and some action buttons. This was using a third-party site. This analysis was using the robots.txt. And after getting the robots.txt, we save the exact output as well. Along with, we make it link so that you can just click. Who has the time to copy paste? Just click on the links, you will open up another thing. This is the request which was done for that. The information, this is for rating. You can rate it as anything you want. These are different rating levels, severity levels. For robots.txt, yeah, this is the place where you can write some notes. For robots.txt, it really doesn't matter you run a passive or semi-passive plugin, because both the things will get the same thing. And like, I don't think it is legally not advised to fetch robots.txt. Semi-passive plugin also had a similar finding here. So yeah, next get back to we added the rating, so it turned up here. As we launched Arashni is proxified. We have all those transactions right here. So 511 transactions already. Arashni did all those transactions, so we have it in the log. You can search for anything. I was searching for Apache, and then I realized demo.test file doesn't run Apache. Then I went to server to search the server header to see a match. Oops. This is important. The capability to search responses, response bodies, response headers separately is really important. Like, it is the key part of any web application testing. So you can just glide through the transactions, the search results like that. Yeah, you can search response bodies. You can search response codes as well, which is sometimes interesting. Like here, I was searching for 500 errors. There are some weird, stupid errors. Yeah, you can see these errors right there. And yeah, some 404s. I don't know why I did that. So yeah, next is workers. Come on. Workers are the processes which run your plugins. These are really important. So here what I'm doing is, Arashni is already launched, it's running. I can simply pause it. So a snapshot of the process is taken, it's stored, and when you want to resume it, it will resume from the state it was left off. This is simple Linux signal magic, but really useful. Yeah, now we have something called work list as well. Like, as soon as you launch some plugins, after you launched, oops, you realize that, oh, maybe I want something else to be done first rather than all the plugins I just launched. So we have something called work list, which lets you control the work which is present in the queue already. So these are the works which are still to be executed. That's the estimated time. On the course, OWTF will learn the estimated times. I just paused all the plugins because I wanted to run this plugin first. So when I tried to run it, I realized that it would have initiated immediately. But then, when I visited the workers page, come on, I found that something else was already running. I was launched this. So I switched back. I saw that OWTF has launched Harvester because I selected in the passive plugins. But Harvester takes time. I don't have that much time for the demo. So I just kill the plugin. It's really easy to kill commands as well. See, search route interrupted by the user. It's really handy. You don't have to remember all those command line flags. Then, for example, like this plugin was launched, and as soon as it was launched, you can see in the workers, it got alerted. So this is how you work. You work in the front end. You don't go and remember the flags and stuff. These are all the plugins which have completed their execution, which are passive plugins. We give different resources, some search engine stuff. Yeah, we interrupt with the harvester, so we save whatever output we got. So it really doesn't matter. Even if you quit in the middle, we ensure that it's a clean quit. So you get the data intact of whatever tool it was run. Yeah, that's it. Thank you. On to my colleague.
Okay. Okay, I'm going to present you WAF bypasser and botnet mode. They are both integrated into OWTF. Okay, who am I? My name is Kourtesis. I'm an OWTF contributor for about 1 year. I'm security researcher, author of botnet mode and WAF bypasser. So what is botnet mode? Botnet mode just allows the users to simulate a botnet attack. That's what it does. So how does it work? It's sending all of the HTTP requests through a different proxy. So it has two modes, proxy switching and Tor mode. So proxy switching is HTTP requests through different proxies. Proxies can be fetched automatically by a feature called proxy miner. And the other option, the other mode is Tor mode that will pass through the Tor network, and we can change, renew the IP after a user-defined time. So here I have a demo. How can I start this? Okay, here I'm deleting all of the log files, demonstrating how it works. I'm starting the web server. I'm running a botnet mode using a proxy list. Here we can see that we are taking the proxies. We have 14 proxies in the list, and 3 of them are live. Right now I'm going to the web interface, adding my target. And I'm running Arachne. And right now we will see the logs of the server. And we can see that we are passing through different IPs. And here we will see the proxy list, which contains all of the IPs that we passed through. Here is the list of the proxies that we checked. And here we are matching, for example, this IP is somewhere there. And after a while, we have all of the HTTP requests. So that's the one demo. And right now, the proxy miner. This feature is mining proxies from the web. Here we can see that we face it from these websites. One failed, but the miner continued facing from other websites. We can see that it has faced 1,700 proxies, and after a while we found that we have about 550 proxies alive, so we can run the test with 500 different IPs. So we can prevent potential IP blocking and whatever. Right now, I'm going to talk to you about another feature. It's called WAF bypasser. And WAF stands for Web Application Firewall. So it's a project integrated into OWTF, and it's a standalone project as well. and it's trying to bypass web application firewalls or written virtual patches. It's important to pinpoint that during the research and the development, we found some 0-day exploits, and I'm going to present one of them. Okay. Right now, oh, can we post? Yeah. Can we show the configuration from the? Okay, I have configured the web server with Apache Mod Security Web Application Firewall. It's from DigitalOcean, and it says, okay, we'll use this dumb vulnerable web application, and we will try to make it secure. So let's see how secure this web application is with Mod Security and OWASP core set rule set. So right now we're fuzzing against the Ubuntu virtual machine, and we are trying to detect all of the blocked characters. We will encode them and we'll send them. No, this is not with them. This is the other one. This is the exploitation. I have one more. No. Is it the same? Okay, one says detect. Yeah, this one. Yes. So we'll try to detect all of the accepted characters and the blocked characters. We can see that these are the undetected characters. The quotes are blocked, and we are trying to encode them. And as we can see here, can you pause it? Here, if we send a double quote in between two accepted characters, it's undetected. So we'll use this to exploit our target. Okay, can you? Oh yeah, here we are testing that a single quote is blocked, and if we add a single quote in between with characters, we will not. Okay. Oh, is this the other video? Yeah, this is the other video. Okay, can you play the new video, the second one? This one? Yeah, from the beginning. Okay, in this video, we'll fuzz the target with some payloads, and we'll see which payloads are detected and which are not. The other one is the same. It's the characters.
This one?
Yes. Yes, yes. Yes, from the beginning. Okay, we can see that we are specifying the mode, the target. We can see the payloads. And we can see here a list of detected payloads, which are the HTTP requests, and undetected payloads. So if we try to detect the payload, we will end up with a forbidden error message. And if we try one undetected, we'll see this message. So this is the latest Ubuntu package, which includes an outdated version of the core set rules, and we can see here that can be bypassed. And that's all for me.
Which is a re-architecture in the OWTF project.
First, I am a 23-year-old software engineer. I work in Madrid in a company called 11 Paths. It's dedicated to the development of security products. And I'm an OWTF contributor since the Google Summer of Code last year. This presentation is about some issues that some of you have already talked about, which is the importance of good practices in development and maintainability and so on. You are asking yourself why a software engineer presentation in a security conference. The truth is that if you build your own tool, it's all cool until sometimes that you find that the code, some parts of the code are not clear enough, difficult to read, and difficult to maintain. So sometimes I think it is necessary to stop and think that, can I improve my code? Can I reduce that cost? I'm going to talk about some concepts like an interface. An interface is like a contract, like an API that one component offers to its consumer. Another important concept I'm going to talk about is the component coupling. Two components, I consider that two components are coupled when if I change the implementation of one of the components, the other has to change also. Okay. And I have applied some design principles to this re-architecture project, which are some of the SOLID principles. SOLID is an acronym that stands for 5 principles, but I'm just talking about 3 of them. It's the single responsibility principle, which is that it says that one class or one component should have only one reason to change. The interface segregation principle, which says that it's better to have a lot of interfaces or a lot of classes, small classes, than a very big and fat interface. And the last one is the dependency inversion principle that says that it's better, well, our components should depend upon abstraction and upon concretion. It means that if I depend upon an abstraction, if I change the implementation details of some of the components, other components won't even notice, so I don't have to propagate those changes. I started in the Google Summer of Code last year, and I saw some of the previous architecture. There was a main core object that holds an instance of every other module. And if one module depends on another module, it has to traverse a tree-like structure to get that dependency and invoke its interface. This leads to a code-dependent architecture and tightly coupled components, a component there are coupling between the core and the components and among components. I have tried to change this architecture. First of all, I call component a class which is normally instantiated once it is reused by other components. So I call it a service because it provides an API to other components. So I introduced the service locator pattern. It's like a class or an object whose responsibility is to store and retrieve components from in-memory storage. And after doing that, I replaced the tree-based structure with the service locator. After that, I realized that I needed an initialization process, but I didn't know the dependency between the components. So I built some scripts to parse the huge OWTF code base, and I built a graph which was very big. There were a lot of dependencies. So I coded a short script that, with a basic graph algorithm, I determined the instantiation process, the instantiation order. I had some problems like cyclic dependencies, but finally I got it working. Another refactor I performed in the OWTF code base is that I took this fat interface called core, and I extracted a lot of classes that where the core is not responsible, for example, for file-related operation or network-related operation. Finally, I found a meta class in the Python built-in library called abstract-based class that forced a developer to implement some of the methods declared in the abstract class. Normally in Python they use duck typing, and this is not so maintainable because one developer could remove or add new methods. Is not forced to implement a set of methods. So using this abstract-based class, I force the developer that if he changes some implementation, he has to keep at least some methods that all the other components in the framework are relying on. Using that abstract-based class, I made it easier to change implementation of a component or even re-implement some of them. And that's all.
Yeah, and these are the links which you can click off. He's Alessandro, as already told, and the second one is the third one. So yeah, we will be releasing soon our real super stable release in like a year, because we almost rewrote the whole thing because we had some issues in the code base, as he already told. So yeah, please give it a try, or if you want to, we are having stickers as well. Even Ryan has it. You can ask any of us. And if you really like the t-shirt, you can submit a feature or even a one-line bug fix. We can get you this. So yeah, if you want to know more, talk to any one of us. Thank you, and any questions? As always, there are none. So we finish it here.